Hello, everyone, and thank you for coming to this presentation. I'm very happy to also share my little knowledge with this community, this conference, Confer Conf. It's a pleasure for me to start being in this conference. What you see here is not a virtual background. Nowadays, we are using a lot of virtual things. So I'm very proud of it. I always have it in order to remind myself that someday I will probably be there. Who knows? So, but you are not here to take a look at my wallpaper. So you are here, I expect, just to see what it is, this thing, Kubernetes operators, and also in Java. So I can assume that some of you already have some knowledge about Kubernetes operators. Most of you probably in Java. But what it's not so common is that people are using Java to create those operators. If you go to, for instance, Operator Hub, you will find several operators in Java, but it's not the majority by far. So most of the operators are created using Golang, but there are other languages also creating operators, Python. But I will try to explain why in our team we decided to go for Java in order to create Kubernetes operators. Let's start with what is the agenda of this presentation. Well, first, I will introduce myself. It's important that you know who is talking to you. I think so. And also, what can you expect of this presentation? So it's important at the beginning to set your mind in order to see what you are going to receive from this presentation. Also, basically, which was the problem that we were trying to solve when we created operators using Java. So it's not, well, basically, yeah, it's about why operators and why operators in Java. Then I will introduce you on the process of creating operators. Well, first I will introduce you what are those operators. For those of you that do not know what are operators, probably it's worth it. For those of you that already know what are operators, sorry. So which is the process of creating the operator, testing it, publishing, and also what it is, the execution process, but not from deep in the operator, but from, let's say, the user that installs your operator. Okay, so I will show you, especially in OpenShift. This is the more graphical one that I have. In the end, some references that can help you if you want to try operators in Java. And finally, a big thank you and hope not to waste your time. So first, who am I? Well, this is a nice image that can put context around me. I started when this computer saw the light, and I started doing my first things using a computer similar to this. It's interesting, the capacity, memory, and CPU compared to my daughter's mobile phone. Well, time changes or flies. So who am I? Basically, I'm the guy over there that it is being used as a canvas. And well, I'm Java champion. I'm co-leader at the Barcelona Java user group. Also co-founder of JVC and Conf, a conference that we host in Barcelona every year. We are going to host it next July, and it will be the 7th edition. And I'm working as a software engineer at Tetrade. It's a company, small one, that deals with Service Mesh, Istio, Envoy, and zero trust. Totally encourage you that if you are interested on the zero trust concept, take a look at the company and ping me if you need more help on that. And well, I've been working for Red Hat in the past, also Gado Technology and NetCentric, and several other companies, but yeah, the space is limited here. Okay, so let's focus on this presentation. What can you expect of this presentation? Well, in fact, I'm going to show you my real experience. So it's not like a magistral lecture where I'm going to teach you anything. So it's like showing you my experience and you watching it. Why I decided to give this approach to the presentation? Well, because as an attendee, I'm more connected to real things than with theoretical speeches. That when you try to do things, well, the grass is not so green. Well, in this case, I will show you my experience. Probably there are things that you could do better, and I expect that. And also, not the only way that you can do things. It's only one way, my way, the way that we did at that moment, and nothing else. So let's be prepared for a journey of real experience of what we did. So basically, we will focus on technology later, but first we need to think about which is the real problem that we want to solve. So basically, we had a tool that we wanted to make it accessible for users in an easy way, and also giving us the power to automate lots of things in the future. Okay, so if you want to deploy an application into Kubernetes, well, there are several ways. You can use direct YAMLs, and user will do kubectl, apply all those YAMLs. You can use Helm charts, very easy, Helm install, and you add the repo, and that's it. But basically, in those cases, it's more or less one shot. So you install things, it's easy. So we could cover the easiness part with those approaches. But then that's all, folks. If you want to automate lots of things, you need to start thinking on a different approach. And what are those things that we could potentially automate? Well, first, as I said, an easy way to deploy your application. First, step one. Okay, we could cover this with a huge YAML that we put somewhere, and user does a kubectl apply -f and the URL of the file. That's it. Published. Or publish a Helm chart, Helm install, my application, blah, blah, blah. That's it. Looks easy. Okay. But if I also want to automate some things, so scaling. Yeah, you can use horizontal scaler or vertical scaler. But what if this scaling depends on other things? Or what if every time that I upgrade my application, I need to do several steps before or later? Or even if I need to automate complex tasks. So let's imagine that, I don't know, given that the database reaches a specific size, then what we need is just to, I don't know, to stop everything, go to a maintenance mode, do a backup, or just simply search for things in another cluster, whatever. So those complex tasks, now, well, you need to a human to do all those things. You can do several things with jobs in Kubernetes, but in the end, an operator that we will see later will make things very easy. Also, we need to understand that nowadays several applications are already using operators for doing everything. So when you create, I don't know, an ingress in OpenShift, then a controller will take care of this ingress and will create a route and will configure it by itself. And if you create an object of certificate request using Cert Manager, so the operator will take this and will react and do few things. So basically, there are several things that are already using operators. Okay, so what if we also want something that takes care of issues? So, okay, several pods are failing. Okay, you can have replica set, and then, well, everything will be started again when a pod fails, but it's simply restarting a pod, more or less. That's it. But what if a pod is failing, you need to check why it's failing and then react to that doing other things before the pod is restarted. Because if not, apparently, what we can enter is in a loop of crash loop, and that's it. The pod gets restarted. Okay, so those triggers that are started based on conditions is something that need or manual intervention or a code that will code all those steps. And finally, what if you also want to have metrics of not your application per se, because you can have Prometheus or wherever, but all these processes, you want to have metrics of them. So how many times those pods have been failing, but why, and which are the other things that were affected. So if you want to have more abstracted metrics that are considering several things, not only individual elements, then probably you need something that orchestrates all of that. And also there is another point, that is, what if you want to auto-tune your applications based on conditions on the cluster? Okay, so if I don't know, if your application is using an embedded database, but once it detects that there is a Postgres installed, then it tries to connect. I don't know, several things. Then you need to something that is checking for certain conditions and then reacting to that. So then we come to a point that operator pattern is the answer. And you could think, okay, but let's explain me what is an operator. So let's jump into a mode. I don't know if you are a fan of The Office TV series, but there's a famous quote: explain it to me as if I were a 5-year-old kid. Let's try to do it. So an operator basically has all these steps, but let's focus first on the let's say the first elements that are not basically the operator. So when we have an application, let's imagine a pet store. And our application pet store is has several pods, several deployments, services, I don't know, whatever element in Kubernetes that you can imagine. But in the end, you can, let's say, wrap all of that saying, okay, I have the pet store application. Okay, that's called the CRD, the custom resource definition. So we are going to define, okay, what is a pet store? Okay, pet store has several properties. Some are properties or logical or business properties. Okay, this pet store, okay, which is the name? I don't know, which is the color of whatever, how many pets it can store, several things. Also, it can have behavioral attributes. Okay, how much memory it is allowed to have, how much CPU, the persistent volume sizes, several things. You can configure that into the definition of your pet store. Then we will create pet stores. So we can have pet store, I don't know, Barcelona, pet store, Oslo, pet store, Paris. Those are implementations of the pet store. And each of them will have apparently different properties. So what we do as a user is we create a pet store Oslo. And then we have the operator that has a watcher that is simply polling the Kubernetes API in order to see, is there anything happening with objects of type pet store? So creating this CRD, we have now created a new type of object in Kubernetes. The same way as there are pods, deployment services, there is a new one that it is called pet store. So our operator will react to changes on elements of type pet store. It can be in any namespace or it can be in a particular namespace. Okay, so the operator receives a change in a pet store object. Then we have a controller that will do several things, several tasks. Okay, I have received this pet store. What are the things that I need to do? The list of things that it needs to do depends on what it is called the reconciliation process, the reconciliation condition. So it's basically the CR tells me a desired state of something, and I have a real state of something. So in the creation trigger, the desired state is I want to have an application with these conditions. The real state is empty. So the task is, okay, create everything. Next step is, okay, I have now a new definition of my pet store Oslo and have changed the memory limit. So the operator, what it does is, okay, I take this, the CR, that it is the desired definition, and I overwrite everything that it is installed. So the goal is to always have the real state and the desired state totally aligned. It also will happen the other way. So let's imagine that someone goes directly to a pod, to a deployment of that application and changes something. The controller will react because there is a change in an object that it is depending on this operator and will say, okay, I don't care what you changed, but I'm going to override with the desired state. So this is preventing anyone messing with your objects. You will always have the desired situation. You can tweak that, and in some cases decide that, okay, but I don't want to override the annotations or the labels because user wants to add some labels to these resources for, I don't know, metrics or whatever reason. So then you can code that you are not going to override the annotations. This is totally up to you, to the operator, in this case, to the controller, to decide what are the things that it's going to do. So now that you first know why you are here, second, who is talking to you, third, what is the business problem that we want to solve, and fourth, what is an operator. Let's jump to the real process of creating an operator using Java. Basically, there are several ways to create operators, as I said before. We can use Helm, Ansible, Go. We could use even Python. There are several ways of doing it. And one of the ways is Java. There are several levels of maturity of an operator. This is totally a made-up scale. So we can go from the basic install and upgrades up to autopilot, that everything is controlled by the operator. Depending on the level that you want to go, it defines which is the languages that you can use. In my case, to create this migration toolkit for applications operator, what I used was OpenJDK 11. For the Java tools, Fabricate Kubernetes client, because in the end you need a client to connect to the Kubernetes API, or not. You could just simply do HTTP requests. But this Fabricate Kubernetes client gives you a lot of stuff already done and typed objects and so on. Also Jib, in this case, to produce the container image. Quarkus as the framework to code above Java, makes everything easier, produces a very optimized artifact, and also allow us to go to Java native. So it's using Java plus GraalVM, then we can have a native artifact that will reduce dramatically the size of the memory footprint and also the speed. So it's super, super fast compared to the traditional way. Then we need tools like kubectl or OC, because those are the clients for Kubernetes or OpenShift. Dive, in this case, just to watch to see how are the layers configured in the container, in the image, sorry. In this case, I was using Podman instead of Docker. And in order to store my images, I had a Quay.io registry. It's similar to Docker Hub, but they don't have the limitation of the number of downloads, and also free, and yeah, you can use it. And as a local cluster, well, I was using mixed. So in some cases Minikube, but in some cases Kind. So in order to create an operator, basically, we start a Java skeleton using the Quarkus website. Then we need to create different YAML files. We have CRD and namespace that are cluster-wide. And then we have a service account, a role, and a role binding, because our operator will use a service account in order to interact with Kubernetes. Also, we are going to have 3 client beans, in this case, namespace to be injected anywhere that it is needed, Kubernetes client, that it is like a general approach client, and CR client, that it is a client, but it's typed. It's only for our CRD type of objects. Then we are going to have a class that will serve as a watcher on those CRs. So something that reacts to changes. Then watcher on deployments. So we need something also that reacts to changes on those deployments that are created by the operator. And also the process to build, push, and deploy, we will use Maven and kubectl finally. So let's take a look to those YAMLs that we need to use in this project. For on the left, you have the Java resources. As I said, we need a controller. Then we need the model, that is the Java definition of the CRD. And then we have like the objects that serve as the main entry point. So the window operator, then we have a producer that is producing the beans. Okay, that's for the Java thing. And for the YAML, well, we have several resources. So we have some for manual deployment. So every time that you want to deploy all the operator and everything, well, you need those YAMLs. And then we have another files that we will use when we deploy our operator into Operator Hub. There is a platform, a marketplace, where users can simply install from there. Regarding those CRDs, so those YAMLs, just only pay attention to the highlighted parts. The rest you can take a look offline. So first, the CRD is the custom resource definition. It says that it is it will be namespaced, and it has an open API definition. So here you have the definition of your object, definition of your pet store. Remember the color, the size of the store, how many pets it can store, memory limit, space in disk, whatever. You define it here. You can define even the type and the default value. And Kubernetes will do a validation once you submit the CRD. So if it's not it's not valid, it will be rejected. Also, we have the role that defines permissions. Okay. Role binding that links a set of permissions, that is a role, with a service account. And then the deployment of our operator that specifies which is the service account that is going to use. So the operator will only do what this role is allowing it to do. Regarding the Java clients, well, we have a global client. In this case, we are producing a bean from the default Kubernetes client. So it will get the connection that you have in your machine in the kube context, and it will connect to the cluster. You can also specify the way of connecting or the way where it gets the context, but in summary, it is the client that connects to the Kubernetes API. Then we have a specific CRD client. We are saying, okay, I want a client for this custom resource definition that it is called WindUp resource. Okay, so we will get types of this element, objects of this type, sorry, and it's a faster way of interacting. Then a CRD context that it is, well, it's per code. I think that in the latest versions, this is no longer needed, but it was time ago when I created this operator. And again, and then the namespace bin that is going to be reused in several places. For the watchers, it's very easy. So we have this basic and main entry point, the operator, where we configure first the CR client watch. So we are going to watch the changes on that type, and we are going to delegate the actions to this WindUp controller that you can see in the middle. And this is implementing a watcher interface that is that has basically three methods. So on add, on update, and on delete. So, well, sorry. In this case, it has one method that it is event received, and then we have the action, and then we delegate to the individual method. So here we are going to say, okay, if you are creating a CR, I'm going to do something. If you are updating, I'm going to do another thing. Basically, in both cases, we could delegate to the same reconciling method, saying, okay, I'm going to override everything that is created with the configuration, and that's it. So if you say to a replica set, instead of 3 replicas, I want now 5, the replica set will kill 2. That's it. And if we want 5 and it was 3, the replica set will spin 2 more. That's it. And then we have another watcher that it is for deployments. In this case is, okay, once the deployment is done, I want to see, in this case, which is the status. But again, we could also say, okay, I'm going to overwrite every time that it is a change in my deployment, sorry, in my deployment with the desired status, in order to prevent that anyone is messing. As I said, the reconciliation process is basically, if the expected status is different than the current status, do something. You can do this check or even don't care about the check. So just simply overwrite every time the configuration. So every time you say, okay, you're a replica set of 3 replicas. Okay, next time that something changes, okay, you're a replica set of 3 replicas. If the real estate is different, Kubernetes will take care. So that's the other thing. So once we have the operator, it's very simple. So it's a collection of watchers and that's it. This is the simplest approach. Things can be very complicated, but from a starting point of view, this is very simple. So regarding the test, okay, I'm not going to cover unit tests because for the individual methods, you already know how to test them. But to test your operator, there's something called Kubernetes mock server that Kubernetes, the fabricated Kubernetes client is giving us, that what we can do is simulate a Kubernetes API. So you simply get the client from this mock server, and then all the calls will be to that mock, and your code will not know that there is no real Kubernetes there. And also you can specify that this server really answers with a logical answer for the CRUD operations. And with that, you just simply check, okay, when the creation has been done, I should expect, I don't know, a few calls to the Kubernetes API, creating a deployment, creating a service, updating the operator, updating a service, a deployment, or whatever. So you can check all the operations that have been, in fact, requested to the Kubernetes API. That way you can just check that from a theoretical point of view, all the flow is correct. Also, you can do an end-to-end test using a local cluster. In this case, you spin up a cluster using Kind that will create a cluster in your machine. And then what you do is, okay, I just simply deploy my operator. And once everything is deployed, I wait for some time, as you can see here with the sleep 20, and then I create, as you see here, I create the CR. So we create the pet store CR to create a pet store. We sleep some time because it takes time to everything be deployed. And after that, I do a kubectl command and I check that the number of objects that I have received is the number of objects that I expected. If so, that means the operator triggered correctly and created all the objects that were needed. This is a very simple test, but with this, you are checking that all the objects at least are created. Further tests should be created in order to check that, okay, the service, the deployment are created, but I also need that they are running okay. So you can improve this test a while. Also, you can move this local test into your CI environment. So using Minikube, for instance, in this case, we are using a GitHub action in order to spin up a Minikube, configure it, then do exactly the same as we did before. We build the operator. In this case, as you can see, as you can see here, well, you don't see mine. In the build operator image on the middle, we are creating the native image of our operator. So no need for using a JVM or anything. And with this, it will create a native artifact, and then it will package into a Docker container. And then we will deploy it in Minikube. In this case, as we do the Minikube, eval Minikube, blah, 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 what we are doing is that we are saying, okay, every image that I'm creating will go to the Minikube registry. We can do another more elegant approach that it is Minikube image load. I can't remember if it's Minikube or kind. One of those can just simply say, okay, load this image, and it will put that into the internal registry. Just to not go outside this sandbox in order to test your operator. Then we deploy, then we create a CR, then we sleep some time, and then again, we do a kubectl get to get the number of objects that have been created. Finally, in order to publish the operator, well, we can use two things. One is operatorhub.io, where you will see hundreds of operators. And also there's another one that it is the internal Operator Hub marketplace in OpenShift, where you can search for an operator and just click install, and that's it. So your users will have access to several things, and it's easy to search, easy to install. In order to publish an operator there, you need to do a pull request to this project, operator framework, and then use those files that I mentioned before. So it's creating a CSV, it's a cluster server version that includes several information. And then with this, you will publish your operator if the pull request passes the tests in their side. This cluster service version is very easy. It's a YAML where you specify which is the container image for your operator, which are the CRDs, which is the deployment of the operator, and then which are the install modes accepted. So this operator can only be installed in one namespace at a time, or is for all namespaces, and also basically the keywords in order to be searched in those marketplaces. And once that is created, then here you have the steps in order to test this publication in your own cluster. So you can use, if it's OpenShift, you can use CRC, that it is a local cluster, local OpenShift cluster, and then with these steps, creating a bundle, and then a package, then you push it to a catalog, to push it to your cluster, and then you will have it in when you search for this operator. The execution flow, when a user comes to the OpenShift marketplace, it's very easy. It searches for, in the operators, searches for an operator, clicks on it, then clicks on install, specify in which namespace, that's it. The operator is installed, and it will be upgraded automatically every time a new version, a new release has been published to the marketplace. Once we have the operator installed, we can use the UI and just simply go there, and you can see here that provided APIs. These are the CRDs that the operator is publishing. With this, you can create an instance. You will have a form where you put all the values for those fields. And once this is created, the operator will react, and it will, in this case, it will create a deployment, a service, replica set, whatever. So everything that it is needed. Those are called operands. And finally, you can just simply consume your application. Regarding all the explanation that I gave, I have given, that was the manual way of creating an operator using Java, but there's an initiative called Java Operator Sdk. I totally encourage you to check them because they are putting a lot of effort in order to create something that scaffolds, creates YAMLs for you, gives you tools to test, and yeah, it's way easier using Java Operator Sdk in order to create operators. And moreover, it also gives a standard way of doing operators with Java. Totally encourage you to go there and check their examples and their documentation. It's very interesting. And it also works for Quarkus and for Spring Boot. This is more or less the approach. So they have a CRD class that will create a CR with a controller, different operands. And let's say the watcher for the operands is called event source. And that's it. With this, you can control all the changes in your cluster, let's say, with controller and event source. These are examples of the code using annotations, basically, controller configuration, and then using interfaces, in this case, the reconciler interface, in order to have the reconcile process. And basically, that's it. Very simple and very interesting to use this JDK. Again, with the CRD classes, the same. And yeah, it will also create the YAMLs for you. So only one point of source of truth, sorry. And the event source that are with the watchers for the operands. References, okay, this is a list of links that you can use. Window operator GitHub project. This is my first operator that created using Java. And then the Kubernetes reference, API, the Fabricate Kubernetes client. They are doing a lot of very interesting work in making very easy to connect to Kubernetes. Also for testing with the mock server. Then Quarkus. For those of you that don't know what is Quarkus, I totally encourage you to go there and check their tutorials and their videos. It's a very interesting framework to use Java to do fast applications and coding very fast. The Operator Hub project, Jeep, in order to create images without having Docker installed, Dive to get the layer information, Podman as a replacement of Docker, Quay as an image registry, and then Minikube and Kind as local clusters that you can use to do your tests. And basically, that's it. Here you have the ways to contact me using my Twitter account, my email. You can check several blog posts in my blog. Also, you can find things about test containers and Quarkus there. And, my projects in GitHub, where you can find also, my personal and professional projects there. Thank you very much. I hope it was interesting, and I would be more than glad to answer any question that you have.